this one. This is the diagram for PNP. This is the diagram for NPN. So whether PNP or NPN, in both the cases, you see the emitter junction, emitter lead is common to the base, is common to the collector. Hence, we name it common emitter configuration. So here the input is basically the base current. Okay, input is basically the base current, and this we are having VBB, and this is VCC. This junction voltage is VBE, and this junction voltage, this junction means collector emitter junction, is VCE. In generally, one load current is placed, load is placed in the collector circuit, and across which we take the output. So this is the diagrammetrical representation of NPN PNP transistor in common emitter configuration. So basically, a transistor is used for amplification factor. In maximum cases, the transistor actually used in amplification factor. So we have seen one amplification. So we have seen one amplification factor in case of common base, which is alpha. Here we will be seeing the amplification factor, which is beta. So basically, the amplification factor is nothing but the collector, the output current to the input current, the ratio. The output current to the input current, ratio of the output current to the input current. And here you can see the output current is IC and the input current is IB. So that means what we are having is we are having the ratio change of the output current, change of the output current to the input current, to the change of the input current is the base current amplification factor, which we denote by beta. Beta is delta IC by delta IB. Once star is given over here, we go to the footnote, we will see that if it is DC, it will be only IC by I. In DC values, for DC values, we consider only IC by I. That is beta. So there should be a relation, which is very important relation in terms of this beta and alpha, means relating this beta. We have beta equals to delta IC by delta IB, and we have alpha equals to delta IC by delta IE. And we always know that the emitter current is the base current and the collector current. So change in the emitter current will be equals to change in the base current plus change in the collector current. So the base current is basically the change in emitter current minus change in collector current. So replacing this IB in beta in terms of the emitter current and the collector current, we have beta equals to delta IC by delta IE minus delta IC. Okay. Now what we are doing is we are just dividing the numerator and the denominator by delta I. If we do so, আমরা যদি করি, the numerator over here is delta IC by delta I, and the denominator, there are two terms. The first term will be delta IE by delta I, and the second term is delta IC by delta I. And we know delta IC by delta IE, the change in the collector current to the change in the emitter current, it is in case of common base, and that is alpha. So beta equals to alpha by 1 minus alpha. So this is a very important relation. Beta equals to alpha by 1 minus alpha. Okay. So okay, fine. current entry, it is clear that as alpha approaches unity, beta approaches infinity. What do you mean by this sentence? Means if the value of alpha becomes 1, the value of beta becomes infinite. Okay. Next, what you have to do, the things what we have done in the common base configuration, we will be doing the same thing over here. We should find out the expression for the collector current. Okay, what should be the expression of collector current? Because we know if the base emitter junction is open, in the collector emitter junction in CE configuration, in the collector emitter junction, there will be a flow of rather current due to the minority gain, right? যেরকম common base So for the expression of collector current, we know I equals to IB plus IC, this thing, right? And IC equals to, how we can write IC, the collector current is alpha times of emitter current, always alpha times of emitter current plus ICBO. IC is alpha times of emitter current plus ICBO. Okay, clear? Where we are getting this one? This we are getting from the common base configuration. This we are getting from the common base configuration. IC equals to alpha IE plus IC. Now since IE equals to IB plus IC, then IC equals to, we are replacing this IE in terms of IB and IC. So alpha IB plus IC plus IC. Here we will get one terms alpha IC, which we are bringing on left hand side. So we will be having IC common 1 minus alpha equals to alpha IB plus IC. So IC equals to alpha by 1 minus alpha IB, 1 by 1 minus alpha IC. So 1 by 1 minus alpha ICBO, this we are saying to be ICBO. This we are saying to be ICBO. In CE configuration, when the base emitter junction is open, okay, how much current is flowing through the collector base junction, collector emitter junction, that is ICBO. And this is equals to this one. ICBO equals to 1 by 1 minus alpha ICBO. How we are getting? We are simply getting, we are just putting the value of IB equals to 0. If you put IB equals to 0, then your IC equals to this much, and that IC is nothing but IC. Okay, clear? So what is the expression? IC equals to alpha by 1 minus alpha IB into this term we are saying IC here, plus IC, not into plus IC. Again we have done alpha by 1 minus alpha is beta. So it means IC equals to beta IB plus IC. So this is the expression for collector current in common base. This is the expression in collector current in common base emitter junction. Sorry, common emitter configuration. Okay, clear?
Yes, sir.
Okay, fine. We will go through the concept of ICO. ICO concept are between when the base is open, there will be a current flowing through the through this circuit, and that is due to the minority. Right? This is in reverse bias always, and this is a forward bias always. So that is due to the minority 8%. That current is IC. You should go through the measurement of leakage current. সেটা আমি আর পড়াচ্ছি না. How to measure the leakage current? The circuit is simple circuit. This is the emitter open, the base collector junction. That you can understand. This is the CV mode. Okay, this is base open, emitter collector junction. This is the output diode or output circuit, output part. So this is emitter common. So this is CE configuration. This is CE configuration. This is CB configuration. And these are the circuit. One RC is over there, one ammeter is over there. Obviously, this will be in the range of what? What is the range or what is the order of the current in reverse bias in a diode?
Sir, microampere.
It will be in micro or nano ampere. It should be in micro or nano ampere. 1 minute hold কর। হ্যাঁ বল। হ্যাঁ জিজ্ঞেস করেছিলাম, আমাকে বলতে পারেনি, আমাকে আজকে জানাবে বলেছে। হসপিটাল ম্যানেজমেন্ট, তাই তো? হ্যাঁ আমি আজকে জানিয়ে দেবো, আজকে জানিয়ে দেবো। হ্যাঁ 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 বাচ্চা বুঝতে পারে, ঠিক আছে। Okay, so we know that the reverse current is in diode is in micro or nano ampere. So তার মানে obviously the reverse current over here will be micro or nano. Simple problem you can see relating alpha and beta. If the value of alpha is 0.9, if the value of alpha is 0.9, see the value of beta is 0.9 by 1 minus 0.9, that is 9. If the value of alpha is 0.98, there is a change and the change is 0.08. The value of beta becomes 49. And if value of alpha is 0.99, see there is a change of 0.01 only from here to here. The value of beta becomes 90. So current amplification factor beta is much more. Base current amplification factor is much more than emitter current amplification factor in CD. Okay, clear? কোনো প্রশ্ন?
স্যার আইসিইউটা কিভাবে পাচ্ছি?
বুঝতে পারলাম না, কোথায়?
মানে আইসিইউ যে কারেন্টটা ওটা কিভাবে পাচ্ছি?
আইসিইউ, এই তো সার্কিট তো, বেস ওপেন, এমিটার আর কালেক্টর যে জাংশনটা সেটাই শুধু লাগানো। এটা কমন বেস, এই কমন এমিটার যে কানেকশন, সেখানে তো তোর অ্যামিটার আছে, সেখানে তুই আইসিডিও পাচ্ছিস। যেরকম তুই আইসিডিও পেয়েছিস, the way you got ICBO, the same way you should get ICBO. Only the change is in ICBO, that is in common base mode. Over there, emitter is open because emitter is the input. In common base mode, emitter base is the input junction and collector base is the output. And here emitter base is the input and emitter collector is the output. So base emitter junction is open. This is the reverse bias output junction. You can get the fact. বোঝা গেল?
হ্যাঁ স্যার।
Next we will come to the input and output characteristics of this common emitter junction, common emitter configuration. So basically coming to the input and output characteristics, we know we are basically doing the IV characteristics. We are basically doing the IV characteristics. This one is a single circuit for the input and the output characteristics. And this is same for all configuration. Only the change is whether we are taking emitter common, whether we are taking the base common, or whether we are taking collector. Okay. So one ammeter is over here, means you are measuring the input current, you are measuring this base emitter voltage, you are measuring the output current, you are measuring base collector emitter. This is the main. Okay. This is VCC, this is VB. So input and output characteristics. Input characteristics, since it is in forward biased. Input characteristics, this is in forward bias. That means the forward bias characteristics will remain. So basically the characteristics is same. Only the difference is if you increase the VCE, collector emitter voltage, if you increase VCE, collector emitter voltage, then the graph will shift. So at constant collector emitter voltage, you have to do this. Even we have done this one only in common base also. Okay, but how the curve is shifting, that is very important. So you should make a chart where you will compare the common base এখানে করা আছে কিন্তু diagram দিয়ে করা along with the diagram you should do that one. The common base, the common emitter and the if you do the chart you will see that comparison will be much more easier for you. See, as compared to CD arrangement, IB increases less rapidly with V. Therefore, input resistance of CD circuit is higher than that of CD circuit. And the common base one, input resistance is higher in the CD configuration. And the graph shifts towards right. Okay. Input resistance, if you want to find out input resistance, Ri equals to delta VBE by delta IB at constant VC. Okay. The output characteristics, if you go to the output characteristics, these are the output characteristics. These are the output characteristics. We have seen the same type of things over there in common base also. I will be just going a little bit regarding this output characteristics. This part we said to be the active region. This part we said to be the saturation region. And this part we said to be the cutoff region. In generally, a transistor operates in active region. It active region and transistor operates in this active region. So these are the output characteristics of CE configuration. Output আর ইনপুট ক্যারেক্টারিস্টিক্স আমি বোঝাচ্ছি কিরকম, কিন্তু তোমরা পড়বে it will learn from the notes, other notes which I will send them. Because বোঝার জন্য এটা খুব ভালো, ওকে, কিন্তু পরীক্ষার জন্য আমি আদার নোটস যেখান থেকে দেবো সেখান থেকে। Okay. So these are the output and input characteristics. You should go through the points. Those are very easy. And output resistance is changing VCE by changing the collector current. And obviously here the input current, which is IB, is constant. Initially in common base one, the input current was IE. So for constant IE. And as you increase the input current, the saturation increases. The saturation. Next, we are coming to common collector configuration. Here, the collector is common to both the base and the input. Okay, the collector is common to both the base and the input. This is NPN and this is PNP circuit. You can understand this is the emitter, this is the collector, and this is the base. Okay. How to find out the emitter? Obviously, the arrow one will be the emitter. This is VCC, this is VBB. This voltage is the base collector voltage. This voltage is the base voltage. So here also we have a current amplification factor because the input current is IP and output current over here is IP. So change in IE by change in ID will be the current amplification factor, right, in common collector arrangement, which is denoted by gamma. So there will be a relation between, just like the relation between beta and alpha, there will be a relation between alpha and gamma also. In the same way, we will do, gamma equals to delta ID by delta IE by delta ID, and alpha equals to delta ICD by delta I. Okay. Since IE equals to IB plus IC, so we are writing IB in terms of this IB and IC. We are replacing this IB of this gamma, and replacing this IB of this gamma, what we are doing is dividing by IB throughout. Throughout means the numerator and the denominator, all the terms of the denominator. So in the numerator you will get 1. In the denominator, the first term you will get 1. And in the second term you will get alpha. So gamma equals to 1 by 1 minus alpha. Beta equals to alpha by 1 minus alpha. And gamma equals to 1 by 1. So next we have to find out the expression of collector current also. So starting from the common base mode, this is the equation of the common base mode. IC equals to alpha I plus ICPO. And since IT, the total perimeter current is the total collector current plus the base current. So replacing this IC, we are having this alpha I plus ICPO plus IB, that means I. Since one IB is over there, we can change it just the way we have done in the common emitter configuration. The alpha I we can change it. We are bringing on the left hand side. So IE taken common, giving you 1 minus alpha equals to IB plus IC. So expression of IE, which is a output current, is equals to IB by 1 minus alpha, ICPO by 1 minus alpha. Thinking that maximum collector current is coming from the emitter current. Maximum collector current is coming from the emitter current. We can write IC equals to IA, and that is equal to beta plus 1 into IB, beta plus 1 into IC. 1 by 1 minus alpha is nothing but beta plus 1. If beta equals to, this is given, if beta equals to alpha by 1 minus alpha, we just add plus 1 over here and plus 1 over here. We will get beta plus 1 equals to 1 by 1 minus alpha. Okay. So in the expression, what we are getting is beta 1 by 1 minus alpha over here also, 1 by 1 minus alpha over here also. Okay. So this beta plus 1 into IB and beta plus 1 into IC. So that is equals to IC, the expression of collector. Generally, out of these three configuration, the maximum application is the common emitter application. 90 to 95% common emitter is applied. Common collector application is very, very limited. Okay, very, very limited common collector application. And common base application is 4 to 8% is common base application. Maximum means it is from 90 to 95%. Maximum application is common emitter application. Okay. And obviously in amplifier. If we just go through a comparison between the common base, common emitter, and common collector, this one we will do, including the diagrams of how we do that. Input resistance in common base is low, in common emitter is low, but in common collector is high. Okay, low in what sense? The low in, it is less than 1 kilo ohm. Okay, it is very low, 100 ohm. It is less than 1 kilo ohm. It is much higher, 750 kilo ohm, much higher. Output resistance, output resistance is very high in common base, high in common emitter, but low in common collector. Voltage gain, it is less than 1, and that is the main reason why we are not using the common collector in our voltage gain about 150, and you can see the voltage gain over here about 500. And we apply for high frequency application, for audio frequency application, and it is for impedance matching. Current gain is less than 1. Okay, appreciable, but current gain over here is very high. So basically, we see that the characteristics of an emitter is much suitable to apply in maximum than the common base approach. This is clear? Do you want to ask any question? কিছু জিজ্ঞেস করার আছে, জিজ্ঞেস করার আছে, জিজ্ঞেস করতে পারো।
স্যার কমন কানেক্টর কানেকশনে আইসিবিও কেন হচ্ছে, মানে মানে সিবিওটা তো কমন বেসের জন্য হচ্ছে।
আগেরটা কি পড়েছি সেটাও আইসিপিও পড়েছি তো কমন এমিটারে।
স্যার ওখানে তো আইসিইও বলছিল।
ভালো করে তাহলে দেখুন। This is the expression of the collector current in common emitter configuration. How we are finding out the expression of collector current in common emitter? Basically, we have taken the expression of common collector. Common collector expression টা সেখান থেকে আমরা কি করছি, আইটাকে রিপ্লেস করছি। আইটাকে যদি রিপ্লেস করি তাহলে সেখান থেকে আইসি ইকুয়ালস, সেখান থেকে যখন আইসি ইকুয়ালস টু লিখলাম, দিস ইজ দ্য expression of the collector current for common emitter. এখানে ICPO আছে। Now what we are doing is বেসটাকে আমরা ওপেন করে দিলাম। We just open the base emitter circuit. If we open the base emitter circuit, your IB will be 0. Remaining will be only this portion. So IC equals to this one, and that IC is due to the minority carrier flowing in the collector emitter junction, and that is why we say that one as ICO, collector emitter then base open, and that is in terms of ICBO 1 by 1 minus alpha IC, and this 1 by 1 minus alpha ICBO is said to be ICO. Have you understood?
হ্যাঁ স্যার।
তাহলে একই জিনিস এখানে, আলাদা তো কিছু নয়। আলাদা কি পেয়েছি, একই জিনিস এখানে। IC equals to beta plus 1 IB plus beta plus 1 ICBO. It should be in terms of ICBO on. Yes or no? Now if you, যেটা এখানে লেখা নেই, now if you open the base collector junction, if you open the base collector junction, means your IB, you are making this equals to 0.
0.
If this is 0, current which is flowing through the emitter collector junction now is the collector current. which is nothing but this one. So collector current, okay, which is flowing through the collector emitter junction, which is flowing through the collector emitter junction when the base is open is only this much. আমি কি বোঝাতে পারলাম?
হ্যাঁ স্যার বুঝেছি।
কেটে গেলে জয়েন করবি আবার। Clear? Understood? Any question you want to ask? Anything? Okay. Only use transistor connection যে দেখো এখানে লেখাই আছে 90 to 95% of all the transistor application is the CE application, and it is the most efficient. And why? Because it has a high current gain, it has a high voltage and power gain, it has a moderate output to impedance input impedance ratio. And for these three reasons, we find that the CE configuration is the most suitable in maximum cases. Okay. And how we are using this transistor as an amplifier in CE arrangement, just you should know the circuit on this one. This is a signal IB, okay. So this is just amplified over here. IC you are getting this much. Clear? যদিও CE amplificationটা এটা জেনে রাখ, এটা তোদের লাগবে না পড়ার দরকার, okay. Not even the load line analysis, সেটা এখন করার দরকার নেই, পড়ায় আলাদা কথা। আমি যেখানটা পড়াতে চাইছি সেটা হচ্ছে, আমি এগুলো সব পাঠিয়ে দেবো, এটা যা এখান থেকে পড়াচ্ছি আদার নোটস থেকেও সব পাঠিয়ে। And saturation points. In generally, now onwards, once you studying about transistor, basically first one will be common base configuration, and henceforth whenever you will go through, you will see everything will be in